Welcome back, deep divers. We're kicking things off this month, March 2025, with a deep dive into a NASA mission that's launching this month.
Yeah, it's called EZIE, and this mission is all about tackling a phenomenon that's both beautiful and potentially dangerous.
Oh yeah, definitely both.
We're talking about auroral electrojets.
Auroral Electrojets.
Yes, these massive rivers of electricity that flow high above Earth's poles.
Okay, so I'm guessing most of our listeners have seen pictures of the Northern Lights,
Hey,
right?
those shimmering curtains of color dancing across the night sky?
Yeah.
Well, those are actually caused by auroral electrojets.
Really? I always just thought it was like some kind of space magic or something.
Though there is a kind of magic to it, but it's the magic of electromagnetism.
Okay, so it's not just a pretty light show.
No, not at all.
These electrical currents pack a serious punch.
Yeah, and one of the biggest mysteries surrounding them is how these powerful currents can disrupt our power grids here on Earth.
Oh, so they can actually mess with our technology down here.
Oh, absolutely.
Huh? I never would have guessed that. So in this deep dive, we're going to unravel the mysteries of these auroral electrojets.
That's right.
We're going to explore how NASA's EZIE mission is going to study them.
And we'll also touch on how citizen scientists are getting involved.
So to understand how EZIE is going to tackle this, we need to start with the basics. What exactly are auroral electrojets?
Well, imagine a colossal, invisible river of electricity surging high above Earth's poles.
Ooh.
We're talking nearly 1,000,000 amps of electrical charge zipping around every single second.
1,000,000 amps. That's mind-blowing.
It is. To give you some perspective, that's more current than flows through a lightning bolt.
Wow. Okay. So how do these massive currents form up there in the atmosphere?
It all starts with the sun.
Of course, the sun.
The sun constantly blasts out a stream of charged particles called the solar wind.
Right.
When these particles reach Earth, they interact with our planet's magnetic field.
Okay.
This interaction creates electric fields in the upper atmosphere, specifically in a region called the ionosphere.
Okay, so the ionosphere is where the action's happening.
Exactly. The ionosphere is this dynamic layer of the atmosphere where atoms are constantly being ionized by solar radiation.
It's ionized.
Yeah, and it's within this electrically charged environment that auroral electrojets form.
So these electrojets are like a direct link between the sun's activity and Earth's magnetic field.
Precisely, and their behavior is influenced by all sorts of factors, including the strength of the solar wind, the orientation of Earth's magnetic field, and even the time of year.
So I'm starting to see why studying these currents is so important. It's not just some isolated phenomenon. They're intimately connected to space weather and how it affects Earth.
Exactly. And while we often marvel at the beauty of the Northern Lights, it's important to remember that these dazzling displays are a visual manifestation of powerful forces that can disrupt our technology and our way of life here on Earth.
Right, we were talking about that earlier. So how do these electrojets mess with our power grids?
It all comes down to electromagnetic induction. When these powerful currents surge through the ionosphere, they create fluctuations in Earth's magnetic field. And these fluctuations can induce currents in long conductors like power lines.
Oh, so it's kind of like a giant invisible generator in the sky, sending surges of electricity down to Earth.
That's a great analogy.
And these induced currents can overload transformers.
Exactly, and that causes blackouts and other disruptions.
Huh? I never knew that. So are there any examples of this happening?
There are. Remember the massive power outage in Quebec back in 1989?
Vaguely. Remind me.
That was caused by a powerful geomagnetic storm that was triggered by a surge in auroral electrojet activity.
Oh, wow. And I was reading about more recent events, too, like the disruption of GPS signals and radio communications.
Right.
During periods of like heightened solar activity. It's a reminder that we're not immune to the effects of space weather even here on the ground.
That's a really good point. And as we become increasingly reliant on technology, the potential consequences of space weather events become even more significant.
Yeah.
Imagine a major solar storm knocking out satellites, disrupting air travel, or causing widespread power outages.
Okay, that's getting a little scary.
It could have a cascading effect on our daily lives.
Yeah, I see what you mean. So it sounds like understanding and being able to predict space weather is pretty urgent then.
Absolutely, and that's where EZIE comes in.
EZIE.
This mission is poised to revolutionize our understanding of auroral electrojets and their role in space weather.
So tell me more about EZIE.
What makes it so special?
Ooh.
Well, EZIE stands for the Electrojet Zeeman Imaging Explorer, and it's a mission designed to study these powerful currents in unprecedented detail.
Wow, okay. How's it going to do that?
It's going to send up not one, but three.
Three?
Yes, 3 CubeSats.
CubeSats, what are those?
They're these tiny satellites about the size of a carry-on suitcase.
Oh, wow.
And they're going to fly in formation orbiting Earth from pole to pole.
So 3 tiny satellites working together to unlock the secrets of these massive electrical currents.
That's right.
That's amazing. So how on Earth can you study these invisible currents from space?
Well, that's where things get really ingenious.
I bet.
EZIE will orbit at an altitude of about 350 miles.
350 miles.
Which is kind of a sweet spot that's too high for scientific balloons to reach, but too low for most satellites to linger in.
Oh, I see.
This unique vantage point allows EZIE to directly observe these electrojets and collect data that we've never had access to before.
That makes sense. And launching in March 2025.
Mm-hmm.
That's right around the corner.
It is.
What are the final stages of preparation before liftoff?
Well, the team at NASA Goddard is busy running final tests and checks on the CubeSats and their instruments, making sure everything's in tip-top shape to withstand the rigors of spaceflight and collect the highest quality data possible.
Okay, so we've got these 3 mini satellites in a prime location to observe the electrojets, but how are they actually going to see these invisible currents?
Ah, good question.
I mean, we talked about the Zeeman effect earlier, right?
Right. EZIE is going to utilize that cutting-edge technique.
That sounds very complex.
Well, it is a little complex. It's called the Zeeman effect, and EZIE is going to use that to map these elusive currents.
Okay, so break it down for us.
How exactly does EZIE use this technique to study these invisible electrojets?
Okay, so imagine this. The electrojets create magnetic fields, right?
Right.
Well, these fields actually affect how oxygen molecules way up in the atmosphere emit microwaves.
Okay.
We're talking about a very specific frequency, 118 gigahertz.
Okay, so electrojets, magnetic fields, oxygen, microwaves. I'm following so far, but how does this all tie back to the Zeeman effect?
Okay, so the Zeeman effect basically says that the stronger the magnetic field created by the electrojet, the more this 118 gigahertz frequency gets split apart.
I think I need like a visual here.
A visual.
Is there like an analogy that can help me wrap my head around this?
Okay, sure. Think of a guitar string.
Okay.
When you tighten the string, the pitch gets higher, right?
Right.
It's the same concept here. The stronger the magnetic field, the more stretched the microwave frequency becomes.
And EZI's instruments are designed to detect these tiny variations in the microwave signal.
So by measuring how much that 118 gigahertz frequency is split, EZIE can create a map of the electrojet's magnetic field strength and direction.
You got it.
That's so cool. It's like taking an X-ray of the invisible, revealing the hidden structure of these powerful currents.
That's a great way to put it.
And that's how we're going to learn about the structure of these electrojets and how they change over time.
Which is crucial for understanding their impact.
This is starting to sound like a high-tech detective story.
Ah.
Using cutting-edge science to unravel the mysteries of these invisible forces shaping our world.
Absolutely. And the best part is that this is just the beginning. Oh. We're going to delve even deeper into the mystery surrounding these electrojets.
I can't wait.
And how EZIE is poised to answer some long-standing questions. But first, we need to talk about the groundbreaking role of citizen scientists in this mission.
Oh yeah, that's what I'm really excited about. Citizen science is such a powerful tool for engaging the public in scientific discovery. But before we dive into that, let's take a quick break to let all this sink in. We'll be right back with more on this electrifying deep dive into Auroral Electrojets and the groundbreaking EZIE mission.
This sounds good.
Okay, so before the break, we were talking about how EZIE is going to use this Zeeman effect to map these invisible electrojets from its unique perch in the ionosphere.
Right.
You mentioned this region of the atmosphere has always been a challenge to study.
Oh, yeah.
Why is the ionosphere such a tricky place to explore?
Well, it's almost like a space no man's land.
A no man's land.
You know, it's too high for scientific balloons to reach, but too low for most satellites to hang out in for very long. So most satellites are either much higher up, observing Earth from a distance, or much lower, focusing on very specific areas.
So EZI is venturing into uncharted territory, exploring a region of the atmosphere that's been largely inaccessible until now.
That's a great way to put it.
But, okay, I want to go back to something we talked about earlier, the impact of space weather on Earth. Why is it so important to understand these electrojets?
Yeah.
How can that knowledge help us protect our technology?
Well, think about it this way. Our world is becoming increasingly reliant on technology. Everything from communication networks, GPS systems, power grids, financial transactions, they all depend on satellites and ground-based infrastructure.
Right.
that are vulnerable to space weather.
I see.
You've all heard about like solar flares and geomagnetic storms and all that.
Yeah.
But how do those events translate into problems down here
Exactly.
for our technology?
Yeah, how do they actually cause problems?
Okay, well, remember how we talked about electrojets inducing currents in long conductors? So during a major space weather event, these induced currents can be incredibly powerful and cause all sorts of problems.
Like what?
Well, they can overload transformers in power grids, which leads to blackouts.
Right.
They can disrupt radio communications, GPS signals, affecting navigation and timing systems, and they can even damage satellites in orbit, potentially disrupting communication networks and other critical services.
So it sounds like a major solar storm could essentially just throw our modern world into chaos.
Yeah, it's not an exaggeration.
Wow.
And in fact, there have been some close calls in recent history.
Really?
Yeah, like in 2012.
Okay.
A massive solar eruption narrowly missed Earth.
Oh, wow.
And if it had hit us directly, the consequences could have been catastrophic.
That's unsettling.
Yeah, it is.
So this EZIE mission is starting to sound even more important now.
It is. It really is.
The more we understand about auroral electrojets and their role in space weather, the better we'll be able to predict and mitigate these potential threats.
Absolutely. EZIE's data could be invaluable for developing early warning systems for space weather events.
Oh, that's so cool. So imagine being able to forecast space weather like we do with the weather here on Earth.
Right, exactly.
That'd be amazing.
And then we could take steps to protect our critical infrastructure and minimize the impact of these events.
That's incredible. So, this all sounds very high-tech and complex, but I'm also intrigued by the human element of this mission.
Okay.
You mentioned citizen scientists playing a role in EZIE's research.
Yes.
Can you tell us more about that?
Sure. EZIE isn't just about cutting-edge technology and scientific breakthroughs. It's also about engaging the public in space exploration. The mission team is actually working with students and volunteers from around the world to collect data from the ground using these special magnetometers.
So it's like a global network of space weather observers.
Yeah.
Working alongside the scientists and engineers at NASA.
That's a great way to put it.
Oh, I love that.
These citizen scientists will be collecting magnetic field data from their locations.
Yeah.
Providing a valuable ground-level perspective to complement EZI's measurements from space.
This makes this whole mission feel so much more accessible.
Right.
Inclusive. It's a reminder that space exploration isn't just for a select few.
It's something we can all be a part of.
Exactly. It's a testament to the power of collaboration.
It really is.
Bringing together scientists, students, and volunteers from all walks of life.
Yeah.
EZIE's demonstrating how we can all contribute to our understanding of the universe.
It's amazing, isn't it?
It really is. I remember when I was a kid, I used to dream of becoming an astronaut. I would spend hours reading books about space and watching documentaries about the solar system.
Oh, yeah, I did too.
This kind of project would have blown my mind back then.
It's incredible.
It makes me wonder how many future space explorers are out there right now, inspired by missions like EZIE.
I bet there are quite a few. And it's incredibly inspiring to think about young people all over the world gazing up at the night sky and knowing that they're playing a role in unraveling its mysteries. Who knows? Maybe some of these students participating in EZIE will go on to lead their own space missions one day.
I hope so. Okay, so we've talked about the science, the technology, the human element of EZIE. But there's one more piece of the puzzle I want to explore.
Okay.
We mentioned earlier that EZIE is launching during a special time,
right?
Solar maximum. Can you remind us what that means?
Of course.
And why is it so significant for this mission?
Yeah, so solar maximum is basically the peak of the sun's 11-year activity cycle.
Right.
And during this time, the sun is at its most active.
It's most active.
It's producing more sunspots, more solar flares, more coronal mass ejections.
More of everything.
Vaguely more of everything that drives space weather.
Okay, so it's like the sun is putting on an extra spectacular show during solar maximum.
Yeah, exactly.
So this is why launching EZIE during this time is so strategic.
It is.
Because remember, electrojets are directly influenced by solar activity. So during solar maximum, these currents will be at their most dynamic.
They're most intense.
Giving EZIE a front row seat to observe their behavior under these extreme conditions.
That's right. It's like studying a hurricane during hurricane season.
Yeah.
You're going to get the most dramatic and insightful data when things are at their peak.
Exactly.
So by launching during solar maximum, EZIE will have the opportunity to observe the full range of electrojet behavior.
Wow.
From subtle fluctuations to massive surges.
That's incredible.
This data will be invaluable for understanding how these currents respond to different solar events and for developing more accurate space weather models.
And I read that EZI will be working in conjunction with other NASA missions, like PVC.
You did your research.
Which is studying the solar wind.
Yes.
So it's like a whole team of space detectives out there, piecing together the clues of space weather.
It really is.
This is all incredibly fascinating.
I think so.
I have to admit, my brain is starting to feel a little overloaded.
I get it.
We've covered so much ground today, from the science of auroral electrojets to the technology behind EZI and the crucial role of citizen scientists.
It is a lot to take in.
It really is.
Yeah.
But it's also incredibly exciting.
It is.
To think about all the new knowledge and discoveries that await us, thanks to missions like EZIE.
Yeah, we're on the cusp of a new era of space weather understanding.
That sounds like it.
And the implications are profound.
So before we wrap up, I want to leave our listeners with a final thought to ponder. So imagine, if you will, a world where we can predict space weather events with the same ease and accuracy as we predict the weather here on Earth.
That really is the ultimate goal, isn't it? Having the ability to forecast solar storms, geomagnetic disturbances, even the intensity of the auroras.
Yeah. It would be revolutionary, right?
Okay.
We could protect our power grids, safeguard our satellites. We could even plan space missions with greater confidence, knowing what kind of space weather conditions to expect.
Absolutely. And it's not just about protecting our technology either.
Right.
It's about understanding our place in this vast and dynamic solar system.
Yeah.
We're constantly bombarded by energy and particles from the sun, and these interactions shape our environment in some really profound ways.
And thanks to missions like EZIE, we're starting to unravel that complex web of connections between the sun and the Earth.
It's amazing.
Think about it.
Yeah.
These invisible currents dancing high above our heads.
Right.
They hold the key to understanding some of the most fundamental processes in our solar system.
They really do.
It's a direct link between the sun's energy and Earth's magnetic field.
Yeah.
A tangible manifestation of the intricate dance between our planet and its star.
I love that, the intricate dance.
It's mind-blowing when you really stop to think about it. These shimmering curtains of light, the auroras that have captivated humans for centuries, they're not just a beautiful spectacle.
No, they're not.
They're a window into these powerful forces that shape our world.
And EZI is giving us that front row seat to observe those forces in unprecedented detail.
Exactly.
By mapping these currents, studying their behavior, and correlating their activity with solar events, we're gaining insights that will ultimately help us predict and mitigate the impacts of space weather.
It's like we're assembling this giant puzzle.
Yeah.
And each mission, each new discovery brings us closer to completing the picture.
And the best part is we're not just passively observing.
No,
we're actively shaping our understanding of the universe.
Yeah.
Through missions like EZE, through the collaboration of scientists, engineers, and citizen scientists from all over the world.
It's amazing.
We're pushing the boundaries of knowledge and exploration.
So to our listeners out there, I encourage you to check out the links in the show notes to learn more about the EZI mission. You can find information about the science, the technology, and even how to get involved yourself as a citizen scientist.
And if you ever get a chance to see the Northern Lights in person, take a moment to appreciate the incredible forces at play up there. It's a humbling reminder of our connection to the cosmos and the endless wonders that await our discovery.
This is The Deep Dive, signing off until our next adventure into the world of knowledge and discovery.